Hello, my name is Marco Rodriguez, and this is the logic gate project for electromechanical systems. So what we're going to do, first we're going to start off with our components. We got the breadboard, we got our Arduino, we have a 9-volt battery, we have jumper cables, we have a 1 kilo-ohm resistor, we have an LED, and we have 2 transistors. And this project we're going to make AND logic gates, or logic gates and not logic gates. So the first thing we're going to do is connect our Arduino to the breadboard. So we're going to connect the 5-volt to the positive side of the breadboard. And we are going to ground the negative side. Next, we're going to add a resistor to the positive side of our breadboard. Just like that. Next, we're going to connect a jumper wire to the resistor. To another part of the breadboard, right here. Then we're going to add 1 transistor right here to this jumper cable. And since we're first going to make an AND logic gate, we're going to add the 2 transistors in series. So let's connect another jumper cable to the emitter side of that transistor. And then add this transistor, putting the emitter to the jumper cable, or the collector. Just like that. Next, we're going to connect the LED to this last transistor. So we're going to put that jumper cable here, connect it here, and grab our LED and put it right there. There you go. Finally, let's ground the LED. And now, since our circuit is complete, let's connect the 9-volt battery to the Arduino. Our Arduino is connected, but the light is not on. So let's add these 2 jumper cables. So we're going to use these 2 jumper cables as switches. We're going to connect this one to the resistor right here. And we're going to connect this to the base of this transistor. And we're going to connect this jumper cable from this base of the transistor, since it has current flowing, and connect it to the other base of this transistor. And we see that even with the 1 switch on, it did not turn on, but when we added both switches on, our LED turned on. And that is how the AND logic gate works. Now we are going to make the OR logic gate. So basically took everything out except for the resistor, this jumper cable, and this first transistor. And to make an OR logic gate, we're going to put the second transistor in parallel to this transistor. So we are going to place this transistor right here. And it's placed so it's not touching any other wiring. So this is not connected to this, nor this jumper cable, and this jumper cable is not connected to this. So now we are going to add this second jumper cable from the resistor to the collector of this transistor. Now we're going to connect both transistors to the LED. So we'll start with this one. Right there is the emitter. And we'll put this right here. And our second jumper cable will go right there from the emitter of the second transistor, and we'll connect it right here on the other side. Now we're going to add the two jumper cables as switches. So we can add one switch from this side of the transistor, or the resistor, and we can connect it to the base of this first transistor. And we see that the LED is already on. No need to switch on this second transistor. But we can add this jumper cable still to show that even if both transistors are switched on, connect it right here. Hold on. Right there. The LED is still on. And now if we get rid of this first switch, the LED still stays on because of this second switch being on. Now, last but not least, we're going to have the NOT logic gate. And to do that requires us to go from the resistor, or the actual current, and connect it directly to the LED. So right there, it's already going to turn on. And we are going to ground the transistor. So from the emitter, we are going to ground that. Now, we can take our switch, and again, the NOT logic gate only takes one of the resistors. We have the other one right here, or the transistors. And we can get a current right here next to this resistor, and put it to the base of this transistor. And we see that once we have plugged in, the LED is turned on. So again, no current going through the transistor, and current going through the transistor. And that is how we make a NOT logic gate.